All right, so how do we actually go about doing this? Well, as I mentioned, the first thing that you would typically do is you would open up the file. Once you have the file open, you're typically going to layer different streams on top of the file depending on what it is that you're trying to do. So opening the file by itself really doesn't do anything useful for you. It's a raw file at that point, and there's no particularly simple way to just directly read information out of that file. So what you're actually going to do is you're going to put a stream on top of it that allows you to pull in information character by character. And actually, you can put a stream on top of character by character that would allow you to read in an entire line at a time. And that is probably going to be what you would want more often than not. Sometimes you'll need to read it in character by character or even byte by byte if it's binary. But more often than not, if you're dealing with some kind of text, you're probably going to want to have a higher level stream that understands the structure of a line of text as opposed to reading it in byte by byte. So it's not uncommon to have layers of different streams on top of each other that each know progressively how to deal with something bigger. At the very end of that, you might have something that understands how to read a JSON file or an XML file that we talked about, or even perhaps a Microsoft Word file, because it may have a built-in method for dealing with Word files inside of Java. Okay, so let's take a look at some code here. So this is going to be an example of layering in Java. So we started off here and we get a new input stream. This is basically opening the file. All right, so we're assuming that the file name that we're dealing with here is source.csv. And what we are saying is file input stream, we're getting a new file input stream. We're passing it the name of the file, which is source.csv, and we're storing that in a variable which we're calling FIS, which is of type file input stream. All right, to be clear, this is just a variable name. I could call it Bob and it would work just the same. Obviously, because this is an example where you're looking at new stuff, we tried to name it something that was close to what it is that you're dealing with, and this is a file input stream, which is why we got FIS. Okay, so this by itself opens the file source.csv, and CSV would be comma separated. But this is very, very low level. If I were to try and read from this file, it would actually simply be reading it in byte by byte, which is probably not very useful. So this is why we're going to layer something on top of that. So the first thing that we're going to layer on it is what's called input stream reader. So again, we're going to create a new input stream reader, and we're going to pass it the open file that we made in the previous line. So we're taking this FIS and we're passing that as a parameter into input stream reader. And that produces for us an input stream reader, which we're calling ISR. That has the ability to read character by character from the file, which is a step up from where we were reading bit by bit. And now we might want to layer on top of that again so that we can read an entire string. And so this one is called buffered reader, and we would take in a new buffered reader. And again, that one actually takes the previous one as its parameter and gives you a BR. Once you have a BR, you can actually just read from it, at which point you'd be able to read. There is a shortcut to this, which I'm going to show you in just a second, but I do want you to understand that it is common that the raw file that you have decided to open, you would never actually interact with that particular variable. You would layer something on top of that that allows you to then interact with it in a more useful way. The second thing to notice about this is all of this was wrapped in a try-catch. So if you remember from the last class, this try is here because any of these objects or any of these methods may throw an exception. And very specifically, if I were to not put this here, this would not compile. It would tell me that file input stream can throw IO exceptions and I am not attempting to catch them. So I must catch IO exceptions when I'm dealing with each of these. So the try catch here gives me an IO exception as a type. And again, this could just be exception if you want it to be more generic, but IO exception is particularly what you're going to be dealing with when you're dealing with input-output. And this is just simply printing out an error message. So if something goes wrong, for whatever reason, it cannot open the file, then this will happen. Now, you might be sitting there going, but you wrote the code. You obviously know the file is going to be there. Why on earth would it not be able to write the file or read from the file? And again, there are many, many ways that that could happen. You could write an application for your phone, and you could put that in the Play Store. And when the application is first opened on somebody's phone after they have installed it, you could write a file out that has some information in there, like a license key or the user's name or some other information that you're keeping track of. Let's think you're writing a game. You might want to keep the high scores locally on the phone. So you might write a file called high scores. And then the second time the app is opened, it would read in high scores and remember all of the information that was in that file. And you might think you're very, very clever. And why on earth would you ever need to do any kind of exception handling around opening your highscores.csv? Well, the answer is because it turns out you're not the only person who can read and write from that file. If the person's phone were to fill up, or if the person opened up their Files app and browsed into the directory where your actual file is stored for the app, they could just delete it. They could also reinstall the phone, at which point, without the particular file being there, you have to deal with the fact that it's not there. And so in that circumstance, normally what you would do if you were dealing with like a high score is after you try to open it, if it's not there, in the catch, you might just go ahead and create it, because the assumption is you're starting over, or this is the first time it's been installed, or whatever else. So again, very important that you deal with exception handling when you are dealing with files, because the world around you will constantly change. Users will go in and delete files, they'll add files, they'll do all kinds of terrible things to you. They'll make the file system completely full, which has nothing to do with you, but all of a sudden you aren't able to write to the file that you should have been able to write to. So that's why you have to keep doing exception handling. Okay, so here's an example of structured information that might be in a file. So we might have an airline, and that airline might need to keep track of all of their flights. So for example, you might have a flight number, which might be AA123, apparently American Airlines. The origin airport might be BWI, which if I'm not mistaken is Baltimore, Washington. The destination airport might be San Francisco. The number of passengers might be 235, that's a big plane, and the average ticket price was $239.50. That seems low. All right, but anyway, so from Baltimore to San Francisco, this is one line of data. And so the example here is that we may have a file where we have a bunch of these lines of data. Here's another flight down here, and so on and so forth. And as time goes on, more of these are added in, and we now have the ability to calculate what is the average price of flights from San Francisco to Baltimore, or vice versa, or how many flights left today might be a question that you might want to ask. Maybe it's a different file every day that lists all the different ones. So this is a comma-separated file. All right, so we're going to do this airline example, and we're going to do it in both Java, and then we're going to do it in C#. So what I'm trying to do here is I'm trying to read in that file, and I'm going to print out some of the data that's in there. All right, so we start off, and you're going to need a couple of imports up at the top. Very specifically, you're going to need java.io. There's a bunch of different ones inside of java.io. It's fine to just import java.io.star, and that'll give you all that. You may also need Java utilities, so we'll go ahead and add that in. All right, so we have our main method. Everything is hunky-dory so far. We're going to have a try and a catch because we're going to deal with file stuff. So that all looks good. We initialize a string to empty, and we are going to open up a file. I did mention that there was a shortcut in Java for opening up the file and not having to have 3 layers of things on there, and that's using scanner, which you had also used for reading input from the user on the console. So we start off and we create the file. So a file name, which is not anything to do with the actual file name on there. This is just a variable that we are going to keep track of inside of our code. We're calling it myFile. Gets new file and then the file name. This is the actual file name on the file system. So that's what it's actually called if you were to open up Windows Explorer or the Mac equivalent, which is File Explorer or something like that, I think. So this gives you a variable called myFile, which has an association to a physical file on the file system. The next line you will be familiar with, which is scanner. We're going to call the variable scan, gets new scanner, but this time instead of passing it system.io, what we're instead going to pass it is myFile. So when you did system.io, what you were doing was you were saying, I want you to read from the keyboard. And that was the typical thing that you've done up until now. But this time we're doing myFile, which means I want you to read from that file that is associated with this variable. you cannot just put a file name in here. It does not know how to do that. What Scanner expects to take in its constructor is an object of type file. And the only thing that you really have to do to make that is create new file with the file name. So at the moment that this happens, you now have a variable called scan, which is associated with the file. And what I want you to picture in your head is that that magic little cursor is set to the very top left corner of the file. So the first thing that we're going to do is we're going to do a while loop. We're going to say while scan, which is that variable that we just made up here, has next line. That's not something you ever really had to deal with on the keyboard. Then we're going to do scan.nextLine and assign it to a string. So this is a string that we initialized up here to a blank string. So this reads in the first line out of the file and puts it into a string called data line. So now what I want you to picture happening is that little cursor moved across the first line and carriage returned onto the next line, and it is now sitting at the beginning of the next line. When you come back up to the beginning of this while loop, it checks to see, is there another line? And assuming that there is, it'll allow it to read the next one and go on to the next line, and so on and so forth. Eventually, the cursor is going to get to the end of the file, and at that point, scan.hasNextLine is going to fail, at which point you're going to come out of this loop. If you didn't have the loop, you would only read one line out of the file. Almost every time that you're reading from a file, you're probably going to need a loop because you're going to read in many lines out of the file. So this is a very common block of code. You open a file, you create a scanner, which is based on that file. You say, while the scanner has a next line, scan.nextLine. And that will give you a string, which is the first line out of the file, and then the second line out of the file, and then the third line out of the file. What you do with that data is up to you. So in this example, we're using the split function on a string, because dateline was a string, you'll remember. Data line, not dateline. I think dateline was a TV show. Dataline.split, and split takes in a parameter, which is the variable that you wanted to split on, which is a string. So you specify a string that you wanted to split on, which in this case is a comma. So that's going to break up that line. And if we go back and we take a look at what the line looks like, that's going to break up this line into 1, 2, 3, 4, 5 different variables. And what it actually does with those variables is it's going to put them into an array of strings. So tokens at position 0 is going to have this. Tokens at position 1 is going to have this, and so on. Sorry about that. I decided to choke on air, apparently. All right, so tokens at position 0 would have, oh, come along, you can load, you know you can. All right, tokens at position 0 would have AA123, whereas tokens at position 1 would have BWI, and tokens at position 2 would have SFO, and so on and so forth. So this gives you a bunch of cells in an array, each of which has a string. And then, of course, you could manipulate them however you want to. And in this case, all we did was we printed it out. So it's not a very useful program. It just prints out the original line, even after it's split it up into those separate tokens. So this block of code is a very common block of code that you will end up writing many times, where you read in a file, you pull each line in one at a time, you do something to that line, and then you read in the next line and do something to that. A common thing that you will end up doing is using something like split to break up the line into its various parts, and then you would process each bit however you're going to do it. I'm going to show you an example again in a minute. All right, so the equivalent code in C#. In this case, you're going to make sure you use system.io, using system.io, and then you still have your try and your catch. All of that is still the same, but this time the way that you open the file and read it is a single statement. So you're going to use an object called StreamReader, which takes in a file name. So you're going to say new StreamReader source.csv, and you're going to give that a name, which in this case we called it SR. You can, of course, call it whatever you want. And then, very similar to what we were talking about in Java, you're going to say while not SR end of stream. Okay, so end of stream is it's a common thing that you're going to hear. EOS, EOF. Those are words that you're going to see. EOF stands for end of file. EOS stands for end of stream. In C#, it's literally written out as end of stream, as you see there. But you should be aware that in different languages, these are called different things. It's the end of the file, the end of the stream, whatever you might need. So while not SR, which was our variable that we created up here for our stream reader, while not SR.endOfStream, which means we are not at the end of the stream here, we're going to do SR.readLine, which is very similarly going to pull in one line for us and assign it to data line, which we then use the same split function, it's capitalized in this case, to break that up into a bunch of array of strings. So again, tokens at position 0 has the airline number AA123, and tokens at position 1 has the source airport, and tokens at position 2 has the destination airport. All right, and your exception handling is very similar down here. IO exception is what you're catching, and you're just doing a console.writeLine. So hopefully this makes sense.